Hi everyone, welcome to the peer graded assignment for the course Managing Machine Learning Projects. I'm Manush Sharma, and in this project, I will be leveraging the knowledge and skills to frame out a machine learning application project. We'll be covering the following outline. We'll be talking about the grading criteria, opportunity evaluation, business understanding using CRISP-TM project process, solution validation. We'll also be doing ML system design and then potential risk in production at the end. The grading criteria is picked from the project guideline that was set up by the team. Moving on to the first step, which is the opportunity evaluation. The first step is defining if there is a problem. I've taken a use case of e-commerce catalog where often critical attributes are missing and which leads to poor discoverability of SKUs, leading to poor experience. Can ML really solve it? So we can definitely leverage machine learning to parse product images and extract attributes. This can be used for the enrichment of missing attributes. Does someone care? Well, catalog scorecard is a critical metric for the business unit as it directly impacts the conversion rate. It is often found that the product funnel is better for SKUs where we have more number of attributes defined versus SKUs where some of the attributes are missing. This is the opportunity that we are talking about, where if we feed in some product images from the catalog, it should be able to determine the attributes. These attributes would be fixed based on category to category. Here I've taken one of the use case of a top wear category. Moving to the first step, the business understanding, where we'll define the problem. So target user here is the catalog operation head and category head team. Why catalog operation head? Because their primary goal is to reduce the cost of operation and also improve the velocity of cataloging. The problem statement. So our objective is fairly simple. We'll be determining catalog attributes using product images and description. Why it matters? Because it will improve the catalog go live velocity and it will improve the catalog fill rate. Catalog go live velocity is basically defined as the number of days taken um, by the team to enable one SKU on the e-commerce platform. Um, the faster it goes live, the better it is for us. Catalog fill rate is the ratio of filled attributes to the total number of attributes available at SKU level. How is it solved today? Well, today there is a team of catalogers who are manually performing this action. They are looking at the images and filling in the missing attributes, which is called as enrichment activity. What is the gap in current state? The current state is people intensive. If we want to scale our business, we want to uh, automate some of it. Otherwise, we'll end up doubling the team size. Secondly, the manual process is also error prone since it is highly people dependent. Moving to next, the definition of success. So, what is the expected impact we are expecting here? We are expecting to improve the catalog quality, which is defined as the scorecard. The scorecard should be better. Second, we are trying to improve the customer experiences by providing additional attributes which is currently missing. Metrics. So the outcome metric here is the catalog fill rate. The output metric is the percentage of correctly identified attributes. Targets. So the target outcome would be improve the catalog fill rate to 100% from the 95 for 95% of the SKU. That would actually mean that for if you're feeding in 100 SKUs, 95 of the SKUs should be correctly determined in terms of all the missing attributes with 100% accuracy. What would be the output? We want the accuracy of this model to be 98% or better. Constraints. So there is like few primary constraints. The attribute classification should not be taking more than 2 hours of 10,000 SKUs. Otherwise, it would end up impacting our cataloging velocity. Secondly, the cost of enrichment, why automation should be less than the manual enrichment cost. Otherwise, we'll end up spending more just because of the sake of automation. Business understanding. So here we are identifying the factors. So there are two critical factors that would impact. One is the product image. Product image will help us define all the critical attributes. So that has to be provided. Second is the catalog file. So this is a CSV or XLS file that would feed in the product attributes along with the SKU, and there would be a linking of SKU to the product images where we can actually populate the same. Moving to the process, how would we validate the solution? So here we'll create a machine learning model that would utilize product images and catalog to determine the missing attributes. And this will also provide a probability at which it is predicting it. What would be the validation approach? So before we get into a complete automation where there is a data pipeline defined, there is complete automation around it, we would try to feed in the model through manual uploads of CSV and images. The data that we are feeding is already cataloged and would help us train our model. And once we have the parameters, we'll evaluate the prediction accuracy on the test set. This way, we'll be able to evaluate if the model would actually work without putting too much effort towards integration of data pipelines. Moving to the next, the ML system design, which technology we would like to use. So between cloud and edge, here we would go ahead with the cloud technology. Uh, the reason being that, like if we have tried to explain it in terms of latency, so here latency is not very critical for us. Those minor delays of seconds or minutes won't really create a problem. Um, since the process is entirely asynchronous. Is reliance on internet acceptable? Yes, definitely it is an e-commerce platform. All our data is anyways on the cloud, and internet is pretty much required. Sending data to cloud. Well, yes, there is no customer or PI information in the catalog, so that is not a challenge for us. So choosing between offline and online learning techniques. So here we can technically go with both offline and online, but I've preferred going with the online learning because as and when we get more and more data, which is cataloged by this process, during QC we would be trying to evaluate the model, and if there are any deviations found during the QC process, we would like to immediately feed it back to the training model so that the model is further trained. So online learning will benefit the model with constant improvement based on QC feedbacks. So QC is a pretty standard process where once the catalog is enriched, there would be a quick QC of a sample size of catalog. And depending upon the QC rejects ratio, we would increase the sample size. The QC reject is pretty less on a smaller sample set. The sample set would remain same. Moving to next, will it be a batch prediction or online prediction? Here we would like to keep it as online prediction. The reason being pretty simple, that there is multiple catalogers who would be uploading the file on the platforms, and we would like to ensure the SLAs are maintained and the tags are pretty much in an acceptable limit. The moment a catalog is uploaded in the system, it will run through the um, enrichment process along with the catalog validation process. So there are a few potential risks which I've jotted down. One is around the data and concept drift. So there is like with change in product catalog, let's say new image guidelines come, or new categories are added, or fashion trend change over time, can cause the model to underperform due to shifting in data distribution. Second is around latency. Gradually, when we start training our model and with more and more data, the model might go fairly complex, which may result in slower prediction, which might delay our go live and impacting our TIRP and impacting our turnaround times. Well, that's it from my end. Thank you.